Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 18, 2025, about 3 days ago. It introduces a large-scale video chaptering model that sets a new state-of-the-art, beating the previous best by about 14% in F1 score and roughly 11% in SODA score. The paper is titled ARC Chapter, Structuring Hour-Long Videos into Navigable Chapters and Hierarchical Summaries. And as we will see later, the combination of massive bilingual data and smarter evaluation has big implications for how we organize long-form video content. Also, the authors shared a GitHub repo for ARC Chapter. There you'll mostly find a detailed README explaining the model's capabilities, ideal use cases, and how the multimodal pipeline works, plus a practical Python client example for calling their online ARC Chapter 7 BAPI, including token setup and a full video processing demo script. Figure 1 illustrates what the system actually produces for a long video, turning a motorcycle review into clean chapters and layered summaries. The top strip shows the full video divided into 4 colored segments, each marking a chapter with timestamps. Below that, the 3 rows show the short titles, the richer structural chapter texts, and the very detailed timestamp-aligned descriptions that follow the video timeline. Figure 2 explains how raw video turns into structured chapters and timestamp descriptions. The full diagram shows a pipeline that first samples visual frames and audio, then runs image captioning and automatic speech recognition to get text plus on-screen writing. These streams feed a timestamp interleaver, which creates one unified multimodal transcript. Finally, a large language model reads that transcript and the initial chapter markers, and outputs clean hierarchical chapters and detailed timeline descriptions. Figure 4 shows how the chaptering model ingests different signals and turns them into structured outputs. The diagram places a multimodal large language model in the center, which receives tokenized instructions, visual tokens from a frozen vision encoder, and optional automatic speech recognition text with timestamps. Because any one of these modalities can drive the system, the architecture stays robust when video or audio is missing. At the top, the same core model can emit 3 styles of navigation: short titles, richer structural chapters, or dense timestamped video descriptions. Table 1 shows that the new chaptering model clearly outperforms all prior systems on the VidAtlas 7M benchmark. The table compares short, medium, long, and overall videos using F1 for boundary accuracy, temporal overlap, a structure quality score, and a captioning score. Across every duration range, the ARC chapter version that uses both video and automatic speech recognition achieves the highest scores, which means more precise cuts and better textual descriptions. Table 3 shows that the same chaptering model also dominates on the VidAtlas test set, beating strong commercial and open large language model APIs. The overview box lists short, medium, long, and overall scores, so it captures both timing accuracy and text quality. Grace, the final G column, is a granularity-aware score that rewards segments that overlap well in time and meaning. Across all lengths, the version using both automatic speech recognition and video achieves the best overall numbers. ARC Chapter shows that with million-scale bilingual data and a granularity-aware metric like Grace, automatic systems can segment long videos into precise, human-friendly chapters and rich summaries. That capability matters for education, podcast search, and any platform drowning in long-form video. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.